Hey everybody, so I've been diving a lot recently into exactly how AI models learn words as well as learn numbers, and I've discovered a lot of things within this. And one of the things that I want to dive into specifically within this video is how exactly AI models store and track and utilize numbers, because they don't utilize numbers in the same way that people do. And the big thing within this is, can AI models do math, or LLM models do math? And the thing is that they can do math. They're not the best at math. They're not the best equipped at math. And there's multiple reasons why they're not the best equipped at math. And it all comes down to their architecture. From the ground up, an LLM model is not architected to be good at math, is the bottom line. And it's interesting how exactly this plays out in the real world, and the kind of use cases that we see within this. And then so the big use case that I see that's come up is this word strawberry. And then so I've been testing a lot around this word strawberry, right? And this word is very unique, and I can see now why it is bringing up issues within this. So let's dive into this. So the word strawberry is interesting, right? And so as you can see on the screen here, I asked the model, first of all, how many R's are in the word strawberry? And it says that there's 2 R's in the word strawberry. And I asked this of both Gemini as well as ChatGPT. How many R's are in the word strawberry? There are 2 words in the word strawberry. And then I asked like another word, like how many R's are in the word burrow? And there's 2 R's in the word burrow. And then kind of going back and forth on this, I break down and I ask it how many R's are in the word berry as opposed to strawberry. And then there's only 1 R in the word berry. And then we get to the root of the problem here, right? And then so if we're focusing on the word berry, we can see what happens here. And then so in this instance, we're asking it about berry, B-E-R-R-Y. But going through all of what's happening here, you can very clearly see what happens is for whatever reason, these models, both Gemini and ChatGPT, they tokenize berry as B-U-R-Y, as 1 R within this, right? And then I don't think that they have a individual token for the word berry, like plain. And then it's interesting as you go through this, because I tested out about 50 words as you go through, as compared to berry, right? And then I was able, the only time that I was able to replicate it again was with the word indeed. And then so I went through a lot of different words, and like slurry, flurry, etc., right? And then that's how I was able to deduce exactly what's going on here. And then so with ChatGPT, very first I ask it how many E's are in the word indeed. There are 3 E's in the word indeed. And then I say, okay, so it's, there's something going on here, right? And then how many E's are in dead, and in dead. And then there are 2 E's in the phrase in dead. And then so it's, again, tokenization issues. You can tell in certain words, in certain instances, what happens is that it's tokenizing the letters wrong and the words wrong. It's not that it's counting them wrong, it's counting them correctly. It's counting based off of its tokens. But for whatever reason, the model mistokenizes words, like from the beginning, right? And then so you can clearly see that this process is going on. And then I asked the model to break down its logic up here. I think it was ChatGPT. Here we go. For strawberry, right? And then it says that the first R appears after the T, and then the second R appears after the E. And then I say what exact letter comes after the second R, and then it says that Y comes after the second R, right? So you can tell it's these 2 R's are the same, are 1 R to the model, and that's how it's tokenizing. And then you can clearly see once you break down the logic, as opposed to just like, oh, these models are stupid, they can't count. You figure out exactly what is going on here, and you can see it's a tokenization issue. It's a tokenization issue on certain words. And then so when you see these examples of strawberry, which is a very clear example, like every example I've seen is strawberry, right? And then we can clearly see, like, for whatever reason, this word strawberry, and I think it's related to berry and berry, B-E-R-R-Y and B-U-R-Y, causes these issues, right? And then same thing, I can replicate that issue by using the word indeed, I-N-D-E-E-D, and then also I-N space D-E-A-D, and then it causes those same issues. So you can tell it's tokenizing wrong. Again, not counting wrong, tokenizing wrong. And then so it's, as opposed to like, oh, these models are stupid, and then like, they're never going to work. Like, to me, it's always like, okay, what is the error here? What's causing that error? And then let's fix the error. Right? Like, I don't know, I approach it from an engineer perspective. I approach everything from an engineer perspective. And then so, to me, all we need to do is fix these small and simple issues. And then secondarily, what we should do is not rely on these models overall for calculations, right? So I'll end the video here on that front. Like, how would I personally, like, what's my best solution overall to like calculating and having LLM models actually do math? Going through a lot of this and a lot of testing in this instance, my solution for having LLM models do math is to not have the LLM model do math flat out. Like, and it goes back to architecture, right? Exactly what I said. Like, a lot of testing has shown me that the transformer architecture, transformer models, and LLM models, which are based off of prediction, and then prediction naturally sacrifices accuracy, is very bad when it comes to mathematical equations in which you don't want to sacrifice accuracy. I mean, go figure, right? And then so your basic calculator is very good at that because your basic calculator doesn't sacrifice accuracy. And then so why try to shoehorn into something that sacrifices accuracy when you can just use a calculator? And an LLM model can use a calculator too. Just so, like, if you go through the logic with Gemini very specifically, you find out that Gemini has a Python tool that it has access to called Lens, and then Lens is a calculator, very flat out. And then that's how Gemini very specifically is calculating and counting these words. I've been able to figure that out. How ChatGPT is counting these words specifically, I don't know. ChatGPT says it doesn't utilize any Python libraries to access these, which means it's not utilizing a calculator. I don't know if it's like, that's what ChatGPT says, right? Gemini very clearly and openly says that it is. ChatGPT says it doesn't use any calculators. So who knows there, but I think that's interesting insights overall to end this video on. If you like this type of content, please like and subscribe. Thank you very much.